Hey, calculus kids, this is Dr. Callahan with week 10 Thursday. I hope you guys are having a wonderful week. So here are your three questions. Go ahead and pause the video and answer them on your warm-up log. All right, so today we're going to talk a little bit more about acceleration and velocity and position function. So you know the relationship is that a position function is often represented by s of t or f of x, and then your velocity is always going to be the first derivative of the position function, and then your acceleration is the first derivative of the velocity or the second derivative of the position function. So that is kind of the relationship. So in semester one, we're going to go from position function to velocity by using the first derivative and velocity to acceleration by using the second derivative. Now, in semester two, we're actually be working backwards from acceleration to velocity with integrals and then velocity to position functions with integrals. All right, so last time I saw you guys, you had the guided notes with the videos that are from your textbook. So I asked you to go ahead and pick any of the ones on the left side. And then if you're not quite sure about the implicit differentiation, then go ahead and take a look at the link that's provided. And then we also did some matching in class, so make sure you guys match them. So I'm just going to jump right into it today because we actually have a lot to cover. So today we're going to go ahead and continue on with position functions. Position functions, acceleration, and velocity. And this is your breakdown. So it's kind of our day two with position function velocity and acceleration. Keep in mind that your assessment this week is part of it is going to be on this as well. So this should go hand in hand with that. Okay, so I'm going to have you guys first start the video with an introduction to position velocity acceleration. And it is going to be with Krista. It's going to be actually a really quick little. But before I do that, I will have to share with you guys so you have it. All right, you guys, so let's go ahead and go back to our PowerPoint and we'll talk a little bit more about this. All right, so your note today is going to start on week 10, Thursday, and it looks like this. Here's your page 2. This is actually going to be the page we're going to have our notes. We'll start off with some of the notes on the concept and then jump into an example that has literally all the parts that you could probably get from the AP exam. This is a review of your unit for Unit 1, so it's important not to forget about certain things, especially like the limit definition. All right, and then with that said, let's go ahead and get started. Okay, let's go ahead and focus in on this part right here. We're going to start off with the green side, and it's basically just concepts, and then we're going to go on to the example, which is on the purple side. So let's go ahead and get started on the green side. So here we go. Instantaneous velocity, v of t of the object, is a derivative of the position function s of t with respect to time. So you know that the velocity is going to be the first derivative of the position function. So v of t equals s prime of t. Acceleration, a of t, is a derivative of velocity with respect to time. So in order to find the acceleration, you will need to find the first derivative of velocity or the second derivative of the position function. Average rate of change, f of x from a to b. So that is like finding the slope of the secant. So here you have f of b minus f of a. That kind of coincides with y2 minus y1 over b minus a, so x2 minus x1. Instantaneous rate of change, f of x at x equals c, is equal to the slope of the tangent. Speed is the absolute value of velocity. Because it needs to be positive, you can't have negative speed. Displacement is how far you are from where you started, and distance is the total amount that you have traveled, regardless whether it's in a positive direction or a negative direction. It is important to understand that the following things also is important. So for example, if you have the velocity and acceleration both at a positive, then you know that the speed is increasing. And the t is at a specific time, so both t's are the same number. On the other hand, if v of t and a of t is less than 0, you know that the speed is decreasing. I'm sorry, let me rephrase that. If you have v of t and a of t is greater than 0 and both of them are positive, then you know the speed is increasing. If v of t and a of t is less than 0, but they still have the same sign, then the speed is increasing. On the other hand, if velocity is positive and acceleration is negative, or vice versa, then you know the speed is decreasing. All right, let's go to the next part. Example, if I travel 10 feet from the right side and then turn around and travel 3 feet back to my left, my distance is going to be 13 feet, but my displacement is 7 feet. So to draw a picture that makes sense of this, the difference between distance, which is total amount traveled, and displacement, which is how far you started, how far from where you started, is like this. If I'm looking at the distance, I am going to be going 10 miles and then going 3 miles. So the total distance is 13 miles. In terms of your odometer is not going to dial back just because you went back in a direction. It's still going to add the -3 as in like an absolute value. So you absolutely should think of it as 10, if my pen allows me to, plus an absolute value of -3, which gives you 13 miles. Now, in terms of displacement, which is how far you have traveled from when you started, think of it this way. You're going 10 miles to work. but then you need to drive back to the gas station to gas up before you go home, how much more miles do you have before you reach home? So that's kind of like displacement. All right, next part is speed is increasing when the velocity and acceleration have the same sign. So plus, plus, or minus, minus. Speed is decreasing when velocity and acceleration have opposite signs, so plus, minus, or minus, plus. A positive velocity indicates that particles is moving in a positive right direction. A negative velocity means that it's moving in a negative direction or to the left. And when velocity v of t is equal to 0, that means the particle is at rest because this means slope. And this is kind of like the maximum right there is when the particle's at rest. Just like when you're throwing a baseball up, the ball is going to go up, but then eventually it stops before it plunges down to the ground. All right, with that said, let's go ahead and get started with the example. Okay, so a ball is thrown vertically upward from the edge of a building. It eventually hits the ground next to the building. If the height of the ball at any given time is greater than 0 seconds, because time doesn't go backwards, is h of t equals negative 16t squared plus 64t plus 80 feet? Answer the following questions. And actually, this has 10 questions, but really, I'm going to include 3 more, so we're going to have 13 questions. So we cover anything that is possibly going to be asked of you on the AP exam if they give you a question like this. So sketch a diagram and label values at the important places. So I'm going to draw my building, and here's my building. And here is the ground. I know that this distance here from the building top to the ground is 80 feet. I also know that h of 0 equals 80 because the building is 80 feet. Then I'm going to go ahead and throw the ball. It's going to go up. It's going to be at a rest and then eventually hits the ground. So when it's at rest, because that is the highest point, velocity is going to be equal to 0. When it hits the ground, the height of the ball is going to be equal to 0. And then just on the side, so I have this ready, I know that h of t, which is the position of the ball, is going to be negative 16t squared plus 64t plus 80. So I know that the velocity, which is going to be the first derivative of the position function, is going to be negative 2t plus 64. And I know that the acceleration, which is the first derivative of the velocity, or the second derivative of the position function, is going to be negative 32. So now that I have these 3 things, I think I'm ready to go ahead and answer the rest of the questions. How tall is the building? Well, keyword here is tall. So you're asking about the position function of the building. So you're just going to do h of 0 is equal to, you plug it in, so negative 16 times 0 squared. Come on, let's work. Plus 64 times 0 plus 80. So that is just going to leave you with 80 feet. So the building is 80 feet. Number 3, when does the ball reach maximum height? So a lot of times you need to learn how to interpret the question. So when it says when, it's talking about time. So it's asking you to find t when. Reaching the maximum height is when the velocity is equal to 0. So v of t is equal to 0. I know that my velocity is going to be negative 32t plus 64 equal to 0. So go ahead and solve for t. You would know that once you do solve for t, you have a 32t equals a positive 36 or 64 divided by both sides by 32. You should have t is equal to 2 seconds. Okay, so next question is number 4. When is the maximum height? So when it's asking for the height, you're looking at the position function. So what you're asking to do is to find h of 2. Okay, so then you're just gonna plug it in. H of 2 equals, you're gonna plug it in as a negative 16t squared, so negative 16 times 2 squared plus 64 times 2 plus 80. And you can go ahead and do that just algebraically with a calculator. And after you're done with that, you should have it equals 144 feet. But make sure you know how to do this logistically with algebra, because I won't be able to just provide you with the answer on the test. For number 5, how long does it take for the ball to hit the ground? So when the ball hits the ground, you know that the height of the ball is going to be 0. So I'm going to go ahead and set 0 to the position function. So that's going to be 0 equals negative 16t squared plus 64t plus 80. And I'm going to go ahead and factor that out. So what I can do with this is I can go ahead and take out a 16. So 0 equals a negative 16 t squared minus 4t minus 5. Okay. That 16 is not going to do anything for me. So it doesn't have a variable attached to it. So I'm just not even going to bother with it. But what's inside here, I can actually go ahead and factor that even further. I could do a t minus a 5 and a t plus 1. So then I give my time in seconds, which is going to be t is equal to 5 and negative 1. Well, you can't have a negative 1 second, so I'm just going to cross that out because that's not going to be applicable here. And I am going to just say that 1 doesn't hit the ground when t equals 5 seconds. All right, number 6. When is the initial velocity? Initial means you're looking at v of t, which is going to be v of 0. So I'm going to plug that in. V of 0 is equal to negative 32t, so replace the t with 0, plus 64. So that's just going to give you 64. Number 7, when is the velocity at 1 second and at 2 seconds? So you're looking at v of 1, so negative 32 times t, which is 1, plus 64. V of 2 at 2 seconds is negative 32 times 2 plus 64. You could plug that into a calculator, which would give you 32 feet per second, and then 0 feet per second. With velocity, it's always going to be the measurement in distance over time. With acceleration, it's always going to be the distance over time squared. So notice the difference of units. Number 8, what is the height at t equals 3 seconds? Well, height is just the position function. So that's just h of 3. You know that the height is negative 16 t squared, so negative 16, 3 squared, plus 64 times 3 plus 80. So then once you calculate this, you should have 128 feet. No time because it's just a position function. Number 9, what is the speed when it hits the ground? Speed is asking you for the velocity. So hitting the ground would mean that I am going to set V, when it hits the ground, I know that it hits the ground at 5 seconds. I found that from a previous question. And that question was question number 5. It hits the ground at t equals 5. So t equals 5. So I'm going to do V of 5 is going to equal to negative 32 times 5 plus 64. Plug that into your calculator, and you should have negative 96. So what that means is because speed is equal to the absolute value of velocity, it is a positive 96 feet per second. There is no negative speed. Okay. Number 10. What is the acceleration at 1 second and at 2 seconds? So A of 1, and you're going to do A of 2. It really wouldn't matter because there's no variables. So it's just negative 32 feet per second squared, negative 32 feet per second squared. Okay, now I'm going to actually include some additional questions, which I think are important because in previous years, I've noticed that they tend to add a little bit more. So I'm actually just going to have you guys include question number 11, 12, and 13. And I'm just going to go ahead and type it up here. Okay. So for questions number, a little bit, question number 11, I am going to ask you to find the average velocity. Question number 12, I'm going to ask you to find the average acceleration. And question number 13, you're going to find if the speed is increasing or decreasing at t equals 1 second. Okay, so let's go ahead and do that. All right, so let me go back to the screen share. Here we go. All right, so in order to find the average velocity, remember, if you just find the slope, that is going to give you your velocity. So the slope formula for this is going to be h of 2 minus h of 0 over, oh, and you know what? Find the average velocity. I won't have to give that to you, sorry. I'll have to give you a 0, 2, okay, in brackets. And then I would do a 2 minus 0. So plug that in. It might be easier if you do the second calc option on your calculator for the position function. And you should have 144 minus 80 over 2 minus 0, which is just going to give you 32 feet per second. Question number 12 asks you to find the acceleration, and I'm just going to make up some numbers here between those 2 points. So then for you to find the average acceleration, acceleration is given to you if you find the slope of the, oh, you know what? I'm sorry. Slope of the position function. There we go. Slope of, I should put of, the slope of velocity. So here I'm going to do v of 2 minus v of 1 over 2 minus 1. And again, you might want to do the second calc option on your calculator. And that should give you a 0 minus 32 over 1, which is a negative 32 feet per second squared. Okay, so question number 13 is speed increasing or decreasing at t equals 1 second. So remember, to find the changes of speed, you will have to do the change of velocity, compare it to the acceleration to see if it's going to be a positive or a negative. If they have the same signs, then speed is increasing. If they have different signs, then it is decreasing. Well, you already did that work up here. V of 1 is going to give you a 32 feet per second. A of 1 is going to give you a negative 32 feet per second squared. Given the fact of the positive and a negative, that means speed is decreasing. All right, you guys, well, that is all that I have. So if you would like to go ahead and practice a little more, I will highly suggest that you turn over to the next page, which is right over here. And I have some additional questions that you can use to go ahead and practice. And take a look at the link right here because you do have the link that will also provide you with the steps. I hope you guys have a wonderful, wonderful weekend. Enjoy your Friday off. And as always, stay safe and healthy. Take care.